My name is Jordan. I'm here at the Old 100 Mine in Silverton, Colorado, almost 2 miles above sea level, and this is the chemistry question. An interesting viewer question was posed to me recently. Why do some liquids have color? I cannot explain this without also answering why does anything have color? And this answer requires an explanation of electrons and photons. Light is quantized, meaning it exists in multiples of certain quantities that cannot be further divided. Light is made up of photons, which are elementary particles with no mass. They do, however, have energy. Calling a photon a particle is in itself a bit of a misnomer because photons behave like both particles and waves. I've mentioned before that protons have energy. It turns out that different photons have different amounts of energy. Since all photons are massless and travel at the speed of light, the only way to increase a photon's energy is by decreasing its wavelength. The combination of all possible photon wavelengths is known as the electromagnetic spectrum. Most of us are familiar with this. It contains an order of increasing energy: radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. Electrons, on the other hand, are negatively charged elementary particles with a small mass that orbit atoms. Normally, electrons exist in the ground state. However, when hit with a photon, the electrons can absorb that photon's energy and move to an excited state. The excited state is not stable, so the electron releases a photon to decrease its energy and move back to a ground state. It is important to note that electrons can only exist in certain energy states and cannot exist anywhere between them. In this way, the energy of an electron is quantized. Because electrons can only exist in certain states, they will absorb only certain quantities of energy, and thus only absorb certain wavelengths of photons. What wavelengths are absorbed depends on the energy state of the electron, the atom that the electron orbits, and what molecule it is in on a larger scale. Since colors are just how our brain interprets different wavelengths of light, we can see this effect. If a photon of a wavelength is not absorbed, scattered, reflected, or emitted, it just passes straight through, and the material is said to be transparent to that color. A small amount of water appears clear because it absorbs relatively little light in the visible spectrum. However, a large amount of water will appear blue. Let's look at the absorption spectrum for water to figure out why. We can see that of all the colors, the blue region is absorbed the least. What isn't absorbed can be reflected, emitted, or passed through, so we see the water as blue when there is enough of it to filter out the other colors. The amount absorbed of each color varies by the identity of the liquid, which is why liquids can be different colors and have different opacities. Thank you for watching the chemistry question. Be sure to subscribe and leave any questions or suggestions in the comments below. Until next time.